We're looking for the range of a quadratic expression composed with itself. In other words, p of x is this quadratic expression, x squared plus 12x plus 37. We want to know what the range of p of x is when you substitute it into itself. Now, just a quick review of the range. Domain and range are topics that aren't particularly popular among a lot of people who don't love math. But let's just talk about this function. Let's say x squared, a simple one. X squared plus 6. The range of this function is the set of all possible y values. And you know y, f of x is y and drag, right? So you can write the range as the smallest number would be 6. That would happen when x was 0, right? After that, you're squaring, which yields positive numbers. So it would be 6 to infinity. You could write it this way if you wanted to, okay? And y'all, some people prefer to see it written like this: 6, a little more explicit, 6 less than or equal to y and unbounded, okay, less than infinity. Okay, this is a little more explicit. This is, all these numbers are the values that this function can take on. So we want to find the range of something completely different. It's a quadratic expression composed with itself. Let's see how that's going to transpire, how I'm going to do it at least. Okay, so this is, a lot of this is just straightforward. P of x means you square. Some people like to see two sets of parentheses right here. I think it's kind of superfluous. Won't argue about it though. So it means this, right? P of x quantity squared times 12 p of x plus 37, which is just substituting p of x back in for the x value itself. Now, the algebra here is slightly tricky. I had to think about this for a while, but notice that we can actually factor out x squared plus 12x plus 37 is what I did right here. See, that's common to these two terms. 37 gets left alone, okay? But you see, we can factor out x squared plus 12x plus 37 as a common trinomial factor. And then we have this left, which would be another copy of this. Then all that's left from this, and that's why I made it green, just so I wouldn't confuse myself and hopefully lend some clarity. So we end up with this statement right here. Okay, we end up with this statement right here. Now, what we can do right here is complete the square twice, and we'll get a nice tidy expression. You could write this as x minus 6 squared plus 1. Right, folks? That's completing the square. Okay, we would get a plus 36, but we have to subtract it off from the 37 to give the 1, right? Okay. Now, I hope that's clear. That's complete the square. When you expand this out, oh, this will be a plus. I'm sorry, plus. My bad. This will be a plus. Okay. Now, right here, in a similar fashion, we'll get x plus 6 squared. And again, we have to subtract 36 from 49. That'll give us 13. Okay, and I need to envelop this in parentheses. And then we still have the plus 37. Now, why? Again, we completed the square twice here. Okay. Now, why is this useful? Well, you see, we can see when x is equal to negative 6, these two terms right here vanish, okay? And so what you would be left with, this expression would just be 13. This whole part here would be 13, and then the plus 37. Okay, we get 50. And what does that represent? That represents the smallest value that the composition can take on. Again, folks, we started right here, p of x, did all this algebra, and then we got to a stage where we realized that if we substitute negative 6 into the expression, p of x would be as small as it could be, because these two parts, this part right here would be 0 at negative 6. This part right here would be 0. You'd have 1 times 13 is 13, plus this 37 is 50. So 50 would be the smallest value in the range. So in other words, I'll write down the range, and I'll use the interval notation here. The range is going to be all the values between 50 and on. Okay, so this is really like the equivalent to finding an absolute min. Okay, now if you want to even be more explicit about this, you could actually write 50 is less than or equal to P of x. And we don't have to write down anything about infinity here. For all x. Now we know polynomials are continuous, so let me put for all x, for all real x. Okay. So P of x is strictly, it's greater than or equal to 50. It's equal to 50 when x is equal to -6. So the range is this value right here. Okay. So that finishes that problem, ladies and gentlemen. That's it. I guess we can circle this. The range of P of x is 50 closed interval to infinity. Okay. All right. Thanks for viewing.